So factoring. We are starting with factoring. So in first section, we are going to do factoring using GCF, greatest common factor, and then factoring using grouping. So we have here the process of factoring by removing the greatest common factor is best stated as reverse distributive property. So when you distribute, you multiply. If you reverse multiplying, basically you're dividing. And that's what we're doing. We're dividing all of the terms by the greatest common factor. So just to go over that, consider this expression, 5x squared times 4x to the fourth plus 3. Okay, visually what we're going to do is we're going to go 5 times 4 and get 20. X to the 2 plus 4 would give us x to the 6. And then we would distribute to the 3 and get 5 times 3, 15, and carry over the x squared. Okay, so what we're going to do is we're going to demonstrate how to factor by removing, so just basically going backwards, going from this expression, 20x squared plus 15, or sorry, 20x to the 6th plus 15x squared back to this 5x squared times 4x to the fourth plus 3. Okay, so we are going to work on finding the GCF. So if we want to do that, we want to look at our entire polynomial. We want to find something that divides into each term. So we look at the numbers. They're all divisible by what? We say, okay, well, these are all divisible by 5. And then the largest number that each term is divisible by. And then when we look at the letters, we're going to take the largest exponent that is common to each term, which really means that we're taking the smallest exponent. Okay, so as long as each of the terms has a letter, you would take the smallest exponent of the letters. So an x squared is common in both x to the 6th and x squared. So you take x squared out of it, because you can't take any more than this x squared here. So to complete the reverse distributive process, we write the GCF in front of a set of parentheses. Inside the parentheses, the expression that's left after dividing. So here we said that the GCF was 5x squared, which means we divide both terms by 5x squared. So to write that, you're going to put the 5x squared here where it says GCF, and then in the parentheses, you put what's left after dividing. So you would divide 20 by 5, that would leave you with 4. And then for the exponents, you would subtract. X to the 6 minus 2 leaves you with x to the 4th. Then 15 divided by 5 gives you a positive 3. And these x squareds cancel each other out. So that's what's left after dividing. And we've successfully taken out the GCF. So that's the process. So for example 1, we want to look at this. And we say, okay, 8y to the 5th minus 12y cubed plus 4y. Look at the numbers first. 8, 12, and 4 are all divisible by what number? 4. They are all divisible by 4. Now let's look at the letters. Do each of them have a letter? Yes. What is the smallest exponent on all of those letters? 1. So for y to the first, we'll take just a y to the first out. Okay, so then we're going to take this expression and we're going to divide each term by the GCF, 4y. Okay, so we write our GCF down here. Then we start a parentheses for what's left. So we do 8 divided by 4, and that would give us 2. Then we do y to the 5 minus 1, which gives us y to the 4th. Then we do 12 divided by 4, and that gives us a minus 3. Then 3 minus 1 gives us y squared. 4 divided by 4 will give us a positive 1, and these y's will cancel out. Okay, so just keep in mind 4's don't cancel out. 4 divided by 4 is actually 1. So you do need a 1 there. And that's your answer. And if you want to check your answer, you do the opposite of dividing, and you would multiply. Okay, let's look at these examples here. So we have 14z to the 8th plus 24z to the 7th minus 30z cubed. So let's see, these are each divisible by, is it just 2? I think so. Yep, 2. Do they all have a z? Yes. What is the smallest one? 3. So 2z to the 3rd. So we'll divide each term by 2z to the 3rd. Okay, so we put the GCF in the front, start a parentheses, then we do 14 divided by 2, 7. Z to the 8 minus 3 will give you a z to the 5th. Then 24 divided by 2 gives us a positive 12. Z to the 7 minus 3, z to the 4th. Negative 30 divided by 2 will give us a negative 15. And then the z cubes cancel out. So there's our answer for example 2. So let's take a look at example 3. 5, 40, and 25 are all divisible by 5. And they all have an x. What's the smallest one? X squared. Good. Okay, so we'll divide each term by 5x squared. All right, so our GCF is 5x squared. We start our parentheses. 5 divided by 5 is 1. X to the 4 minus 2, x squared. Minus 40 divided by 5 would be 8. X to the 3 minus 2 is x to the 1. 25 divided by 5 is positive 5. And then these x squareds are going to cancel. No, we do not. So we're going to go ahead and we're going to erase the 1 in front of the x squared because there's something there. If it was just a 1 by itself, we would need it. And then this one here we do not need. So we have x squared minus 8x plus 5 inside the parentheses. Okay, so that's GCF. So when we are factoring, the reason why we look at this first is because this is always going to be the first thing you do. So you always look to see if you can take a GCF out first before you do any other factoring. All right, the next type of factoring we have is factoring by grouping. So factoring by grouping is a type of factoring that uses the distributive property for polynomials with 4 terms. So if you see 4 terms, you're going to go to this method. Okay, 4 terms. Okay, sometimes you can factor by grouping into 2 groups of terms and then taking a GCF out of each group. So here's our example that we're going to go over the steps with. We have x cubed plus 4x squared plus 6x plus 24. So these do not have a GCF because even though 4, 6, and 24 are all divisible by 2, there's an x right there that doesn't have anything in front of it, and then the 24 doesn't have an x. So no GCF there. So we go straight to the grouping. Okay, so factoring by grouping is going to tell us to do this. First thing, split the equation down the middle. So I'm going to draw a line right there down the middle. Okay, then I'm going to look at the left and the right separately. So on this left here, I'm going to say, can I take a GCF out of here? So they don't have a number they're both divisible by, but they do both have an x squared. So here I say these are both divisible by x squared. Okay, so I put the GCF out here, and then in parentheses, I have x to the 3 minus 2 would be x to the first, or just x. Then here, these x squareds cancel, and I would bring down a plus 4. Okay, then I'm going to look at the 6x and the 24. These are both divisible by what? 6. Okay, so here I'm going to go plus 6, and then in my parentheses I have 6x divided by 6. That'll just be x. 24 divided by 6, 4. Notice that these are the same. That's on purpose. Okay, so in order for factoring by grouping to work, these two need to be the same. Because now, what I want you to do is look at this as one term right here. Here's your plus sign separating them. This is the second part of the term. Okay, so this is two different terms. Now these both have something in common, an x plus 4. So we can take out a GCF of x plus 4. Okay, so my GCF is x plus 4, and since it's more than one term, I'm going to give it parentheses. And then I put a parentheses and I write what's left. So after I take out an x plus 4, they cancel out and I'm left with an x squared right here. And over here, when I take out an x plus 4, I'm left with a plus 6. And there's my factors, x plus 4, x squared plus 6. Now, to check it, before you turn the page, you would just FOIL. Okay, so if I want to check this, just go ahead and multiply it out. So here I would go x times x squared, that gives me x cubed, x times 6, 6x, 4 times x squared, 4x squared, 4 times 6, 24. And then that matches what we had before. The 4 and the 6 are just switched. Okay, so you would FOIL it out to check it. All right, so let's look at example 2. So I have 5x cubed plus 25x squared plus x plus 5. It's 4 terms. Can I take a GCF out? No. Okay. Yeah, because this doesn't have a 5, and then this 5 doesn't have an x, so no. So we're going to go straight to splitting it down the middle. And then let's see, 5x cubed and 25x squared. What would be a GCF here? 5x squared. Very good. 5x squared. Okay, so here we get 5x squared. And then we have parentheses. 5's cancel. X, 3 minus 2 is just x. 25 divided by 5 is 5. And their x squareds canceled there. What can I take out of here? Nothing, right? Okay, if that happens, here's what you're going to do. Just take a 1. If I take a 1 out, I'm left with x plus 5. As long as these two are the same, that's okay. Okay, then we factor out the x plus 5. Now, that's a lot of writing, so sometimes I just take a shortcut and I say, okay, if I factor this out, then I have one of these. And then I'm left with 5x squared plus 1. And that's fine to do, just like that. Okay, I factored out the x plus 5, so I write that once. What's left gets its own parentheses, 5x squared plus 1. And then check it. Okay, so you have 5x squared times x, 5x cubed. 5x squared times 5 would be a 25. X squared, 1 times x, x, 1 times 5, 5. Back to the original expression, so you know you factored correctly. Okay, let's take a look at example 3. So 4 terms. Let's put them down the middle. What can I take out of 3x squared plus 3xy? 3x, good. Okay, so 3x. And then these 3's will cancel. X squared divided by x is just 2 minus 1, so it's just x to the 1. Here you got 3x and 3x canceling, leaving you with a y, so x plus y there. What about here? Negative 7x minus 7y. Negative 7. So good foresight in seeing that it needs to be negative because, remember, this has to be the same. So we need this to be positive. So if we take a negative 7 out, that will happen. So if I go negative 7, I have negative 7 divided by negative 7 is positive x. Negative 7y divided by negative 7 is positive y. And then you have the x plus y. And then 3x minus 7. And we have factored by grouping. All right, let's do some practice. I got to find one. I didn't put any on here. So give me a minute. I'm going to give you GCF and factor by grouping practice. All right, here is one. All right, 3 problems for you. All right, let's go ahead and take a look. Oh, lost it. Where'd it go? Okay, there it is. That was weird. All right, let's look at number 1. So this is a factor by grouping. I've got 4 terms. No GCF to take out right away. So I'm going to split down the middle. What can I take out of these? Just an A. And I can do it just one long line or 2 short lines either way. So if I take an A out, AB divided by A would leave us with B. 6a divided by a would leave us with 6. What can I take out of 3b plus 18? 3, so plus 3. And then 3b divided by 3 leaves us with b, and 18 divided by 3 leaves us with 6. So we write the b plus 6 once. And then in its own set of parentheses, we have a plus 3. There we go. All right, what about number 2? You've got only 3 terms here. What can we do with them, though? Was there something after the 25? I thought, oh, there it is. It's like slowly showing up. Weird. Okay, so next to this 6. So what can I do with that? I got, they're all divisible by 5. And then what about the x's? X to the 6, good. Okay, so we have that GCF of 5x to the 6th. So let's see here. This 5's will cancel. 8 minus 6 will give us 2, so that's x squared. 10 divided by 5 is 2, so minus 2. And then x to the 7 minus 6 would be x to the 1st. And then here, these x to the 6 cancel. There it is. And then 25 divided by 5 is 5. So we're left with x squared minus 2x plus 5 in parentheses. All right, and then number 3, 4 terms. Can I take a GCF out of these right away? Well, not, yeah, in a sec. Split first, then 3x. Okay, so 3x here. And let's see, 6 divided by 3 is 2. X's cancel, y is left. 9 divided by 3 is 3, and those x's will cancel. What about over here? Right, so I can't do anything, so remember when you can't take anything out, take a 1 out, but then when I look at this, they're opposite signs, so I need to take a negative 1 out so I can make them the same. Negative 1. So negative 2 divided by negative 1 will give me positive 2y. And then this will be 3 divided by negative 1, negative 3. That way these two factors are the same so that I can write that one time. Yeah, you could do it the other way. That works as well. And then 3x minus 1. So if you did it the other way, if you took a negative 3x out, it would just be negative 3x plus 1 and then negative 2y plus 3. So same thing, just multiplied by a factor of negative 1. Yes, question. So 6 and 9 are both divisible by 3, and then they both have an x. Okay, so that is section 1.